Okay, today we discuss about polarizations. Okay, basically polarization is electromagnetic properties. Okay, the definition of polarization is the property of electromagnetic wave describing the time varying directions and relative magnitude of the electric field vector. Specifically, the figure traced as a function of time by the extremity of the vector at a fixed location in free space, and the sense in which it is traced as observed along the direction of propagations. Okay. Basically, this is the rotations of the wave in direction of propagations. The electric field X component and electric field Y component perpendicular to each other in direction of propagations. Okay. So type of the polarizations: linear polarizations, circular polarization, and elliptical polarizations. Before we discuss about type of the polarization, first we discuss the instantaneous field of plane wave. So now we consider the electric field travel in the negative z directions and can be written as E, Z and T parameter, E AX, EX, ZT, AY, EY, ZT. Basically, this is the X component of the electric field, and this is X component of electric field, and this is the Y component of electric field. Okay. Now this X component and Y component we can write in real part, wherein we can convert into the sinusoidal format. So X component, a real part, we consider real part and real part of the X component. Okay. EWT KZ. KZ means basically this is the K is constants and Z is distance. WT is phase. W is frequency, T time. So now we consider the X naught, EX naught, WT KZ X phi, X phi X. Phi X means phase constants in the direction of X of the electric field. So now we can write in the Ex naught cos WT plus Kz plus phi X. Okay. Similarly, we can write the Y component Ey cos WT plus Kz plus phi Y, where Ex naught and Ey naught are the maximum magnitude of X and Y components. Okay. So now we discuss the linear polarizations. For the wave to have linear polarizations, the time phase difference between the two components must be multiple of n phi, where n is 0, 1, 2, 3 and so on. Okay. And for circular polarizations, the property of the circular polarizations is the magnitude of the electric field in x and y directions are equal, and the phase difference between x and y component plus 1 by 2 plus 2n pi, where n is 1, 2, 0, 1, 2 and so on for clockwise polarizations, and minus 1 by 2 plus 2n pi and 0, 1, 2 so on for counterclockwise directions. Basically, in circular polarization, there are the two type of polarizations: clockwise polarizations and counterclockwise polarizations. Now, if we change the direction, that is in positive directions, then the clockwise polarizations and counterclockwise polarizations are changed. Elliptical polarizations. Now, this is the third type of the polarizations. Elliptical polarizations, the property of the elliptical polarizations, the magnitude of the electric field in x and y not equal. But the phase difference between x and y similar to the circular polarizations. Okay. Now the properties of the axial ratio. How to analyze the polarizations? Basically, axial ratio is the finding from the polarizations ellipse. In this ellipse, there are the two axes, minor axis and major axis. OA is major axis, OB is minor axis in ellipse. You can see OA major axis, OB minor axis. TO is tilde angle. So the definition of axial ratio is the ratio of the major axis to the minor axis. Okay, and the range of axial ratio is from 1 to infinity. At 1, if axial ratio is 1, the polarization is circular. Okay, if the axial ratio greater than 1 and less than infinity, the polarization is ellipticals. Okay, now we discuss about the input impedance of the antenna. What is the input impedance of the antenna? Okay, basically this is the input impedance antenna properties. So you can see this is the basic antenna structures. This is the generator and this is the antenna feed. AB is antenna feeds, this is the generator points. Okay, and this is the radiated waves. So the terminals are designed at A and B. The ratio of the voltage to a current at this terminal with no attached define the impedance of the antenna. Basically, it can be represented as ZA is equal to RA plus JXA, where ZA equal to antenna impedance at terminal AB, RA antenna resistance at terminal AB, and XA antenna reactance at terminal AB. Okay, so antenna in transmitting mode, basically the structure is represent antenna is transmitting mode. The second thing is Thevenin's equivalent of these structures. So we can write the VG generator voltage, RG is generator resistance, and XG is generator reactance. Okay, these three parameters. And this is the generator current, or RL. RL is represent loss resistance of the antenna, or R small r is radiation resistance of the antenna, or XA reactance of the antenna. Okay, so we can write the in general the total resistance of the antenna terminal AB. Okay, Ra equal to Rr and RL, means combination addition of the loss resistance and radiation resistance. If you assume that the antenna is attached to the generator with the internal impedance, so basically the impedance, generator impedance is Rg plus Jg, resistance of the generator impedance, and Rg resistance of the generator impedance, and Xg is resistance of reactance of the generator impedance. So we first we find the current developed within the loop which is given by A. So after calculation the current, total current, the Ig is total generator current of closed loop, and total voltage, generator voltage Vg, and total impedance Zt. So Vg by Za into terminal AB, which Zg generator impedance. So now we can write in resistance and reactance format, and its magnitude of the current is can be write is Vg and total square. Okay, where Vg is the peak generator voltage, the power delivered to the antenna for the addition is given by half Ig square RL. Okay, in watt, unit watt, and that dissipated at heat and dissipated by as a heat dissipated by the load loss resistance RL basically. So basically this is the power, antenna power for the radiations resistance, or this is the power for the loss resistance. Remaining power is dissipated as the heat on the internal resistance Rg of the generator, and is given by this Rg. Rg is basically the power is consumed by the internally generator resistance Rg. Okay, so power divided in three parts. First part, power divided in term of the radiation power, other thing is radiation power, other thing is loss resistance of the antenna power, third is power consumed by the generator by the Rg. The maximum power delivered to the antenna occur when we have conjugate matching, that is the concept of the matching for maximum power transmission concept. RL plus Rg equal to Rg and Xa is equal to minus Xg. So for this case we apply this concept in previous three power concept. So we can calculate Vg by 8 RL or RL square. This is the power for radiation power, and this is the loss resistance power, and third is power consumed by the antenna generator. Okay, so this is the concept of the antenna impedance. Okay, thank you.